Good day. Today we'll talk about the electrochemical cell potential in the hopes of obtaining what we call the Nernst Equation. So from your previous chem subjects and from your previous Math E, you should know that delta G is equal to negative NFE, where delta G is our Gibbs free energy change and it's related to E, electrochemical cell potential, by N, the number of electrons involved in the redox reaction, and F, which is your Faraday's constant, which is equal to 96,500 coulombs per mole. So we know that corrosion would occur when your electrochemical cell is spontaneous. And spontaneity is given when delta G is negative. If delta G is negative, E is positive. Though do recall that the magnitude of the delta G does not really correspond to the speed of the reaction. Thermodynamics is different than kinetics. Just remember this for now. So metallic corrosion is an electrochemical reaction, and as such, we must consider the two electrodes, the anode and the cathode, to predict how corrosion would occur. So first, let's look at the standard cell potential. The standard cell potential is the difference between the standard reduction potentials of your cathode and your anode. Yung standard reduction potential natin is the potential associated with the reduction of ions under our standard condition, and the reduction reaction has the form like this, M plus E minus to form M. So the standard reduction potential, this is the potential associated with this form of equation. Sorry, may truck sa labas. So now let's look at an example. Consider the Daniell cell. The Daniell cell is a zinc copper cell. What is the standard cell potential for this one? So sa standard conditions, we have 1 molar each of zinc and copper ions. Sa zinc natin and sa copper, ito yung reduction reactions nila. Zinc 2 plus 2 electron to zinc and copper 2 plus 2 electron to copper. The standard reduction potentials for both of these reactions is negative 0.762 for zinc 2 plus to zinc and 0.342 for copper 2 plus to copper. In spontaneous electrochemical cells, the one with the higher reduction potential acts as the cathode. So in here, yung copper natin would act as the cathode and your zinc would become your anode. So this one, ito yung mako-corrode. And we will have, since ito yung mako-corrode, mababaliktad tong reaction na to and we'll have the full electrochemical reaction na ganito. Zinc will be corroded to zinc 2 plus while copper 2 plus will be formed to copper during our electrochemical cell. And to get the standard cell potential, we just use our formula. E naught is equal to standard reduction potential of copper minus the standard reduction potential of zinc. This is copper and this is zinc. Getting this one would have a standard cell potential of 1.104 volts. And this is always positive for a spontaneous electrochemical cell. Now let's look at how the standard cell potential interacts with your equilibrium constant. Since the standard cell potential is related to the standard Gibbs free energy, then it would also be related with the equilibrium constant KEQ like this. Delta G naught is equal to negative RT ln KEQ. And manipulating this equation, we would get that ln KEQ is equal to NF, standard cell potential E naught over RT, or E naught is equal to negative RT ln KEQ over NF. So we can piece out the equilibrium constant from the standard cell potential. So let's look at another example. Again, let's consider the Daniell cell. Now let's compute for the equilibrium ratio of zinc 2 plus and copper 2 plus. So again, ito yung reaction natin mula sa kanina. So your KEQ, this is equal to products over reactants. Dapat ito ay copper 2 plus and this is copper. So this will become Cu zinc 2 plus over zinc and Cu2 plus, products over reactants. Pag meron tayong solids or condensed phases, that's just equal to 1. So your KEQ will be equal to zinc 2 plus over copper 2 plus, and equal yan sa exponential of NFE over RT. We already have a value of E naught kanina. So putting all of the required in the equation, there are 2 electrons involved in our redox reaction. Parity is constant. E naught is 1.104 volts. You have R, which is the Boltzmann constant or the gas constant, 8.314 joules per mole Kelvin. And you have 298.15 Kelvin, which is the temperature. We will get the ratio to be a very big number, 2.14 times 10 to the 37. So at equilibrium, there will be 2.14 times 10 to the 37 more zinc ions than your copper ions. And now, let's look at the Nernst equation. So the Nernst equation is something that we use for non-standard conditions, which is almost always the case in our corrosion events, since hindi naman natutupad yung standard conditions at the real world. So for non-standard conditions, your delta G is equal to delta G naught plus RT ln Q. This should be taught from you from Math E 101. So we know that delta G is equal to NFE. Substituting that one, we'll get negative NFE, Negative NFE is equal to negative NFE naught plus RT ln Q. Transposing negative N or dividing all sides by negative NF, we'll get E is equal to E naught minus RT over NF ln Q, where E is your cell potential, E naught is your standard cell potential, and Q is your reaction quotient. And the reaction quotient, para lang yan yung equilibrium constant natin. It's just your products over reactants. Tapos pag meron tayong coefficients, tinataas lang natin by the power of those coefficients. For convenience, we have other forms of the Nernst equation. So we also have this form where we transform the ln to log. So we multiplied it by 2.303. And at 298 Kelvin, or ito yung favorite nating 25 degrees Celsius, we can reduce ito pala, lahat, to become 0.092 volts over N log Q. So E is equal to E naught minus 0.0592 over N log Q at 298 Kelvin. So to conclude, let's look at our final example. Now let's consider a Daniell cell, but this time it is not in standard conditions anymore. The concentration of zinc 2 plus is 1 molar, while yung copper natin is 0.01 molar. Hindi na siya standard condition. So what is the cell potential at 300 Kelvin? To get the cell potential, first we need to obtain your standard cell potential, but we already knew that from our previous example. E naught is equal to 1.104 for this Daniell cell. Now, using the Nernst equation, we place this E naught here, and we have 0.0592 kasi 300 Kelvin lang naman tayo. Malapit ang approximation sa 298 Kelvin. You have two electrons involved in the redox, and you have log of zinc 2 plus and copper 2 plus. Ito yung products over reactants. Calculating for that one, zinc 2 plus is 1 molar and copper 2 plus is 0.01 molar. We'll get that E is equal to 1.04 volts. So hopefully na-remind kayo dito sa ginawa natin. I trust naman nakuha nyo ito sa Math E 101. So thank you, and I'll see you next time.